In this video, we're going to take a full look at the life cycle of requirements from BDD to TDD to unit test to Circle CI, CI/CD. By the way, I'm doing this video in the dark because there's one heck of a lightning show behind me, and I thought you might enjoy that while I'm speaking, but nonetheless, it's unpredictable, isn't it? I'll see if we can get a little better view over this way, but nonetheless, so we're going to take a look at the full life cycle of requirements, and this is really neat. The approach that we're going to take here, I think, is going to be really neat because in the old days, a product owner would come up with a requirement, and then we'd write the code, and then there was a very manual process to figure out, are we complete? What's our progress look like? Things like that. But now with this approach that we'll talk about here, a lot of that gets automated. So you can write the requirement, and that ties directly to what we're going to call given when thens and some behavior-driven design. That becomes a script to write a unit test. We write the unit test using test-driven design, knowing it will fail because the code has not been written yet. Once the code has been written to fulfill the requirement, then the unit test will pass, and we can see that in a CI/CD pipeline. Now, what else is neat about this is we could put the requirements somewhere like Jira, where the requirements start as basically an idea, and then from that we can create an epic out of it. From the epic, we can create stories. Now, neat thing about Jira is it has really good integration with GitHub. So from the story, you can go directly to the GitHub feature branch where the story is being developed. And then the cool thing about Circle CI is, guess what? It has really good integration with GitHub. So once you're in the feature branch, you can take a look at the CI/CD pipeline. If it's red, requirements not yet met. If it's green, then it means that that pipeline has passed, and that gives us an indication that the requirements were met. Well, gosh, I'll tell you what, with this show going on behind me, I'm tempted to stay in full screen mode, but I put all this time into a PowerPoint presentation, so I guess I might as well jump in. Okay, think about the old days a little bit prior to Agile. And I'll tell you that I took a class in project management when I was in graduate school. I took it from Dr. Amitabh Ratturi, one of my favorite professors I had. Had a lot of really good professors back then. And this was around 2000, 2001. At that time, Agile, as we know it today, didn't really exist. And we used waterfall for software projects. And there were some challenges with it. Let's take a look at how waterfall works. And don't get me wrong, there are definitely times to use waterfall. There are times that we need to know budget, we need to know timeline in advance, and we have history to know that. But the trick with software is that every software project is different because software is always evolving. We had I think about in my career the advent of the internet, the advent of the mobile phone, the advent of the search engine. The advent of cybersecurity, the advent of cloud, artificial intelligence. Everything that I just listed to you was not common when my career started as a software developer. And you see, all of these things we pivot and we adapt to. So waterfall approach, what we'll typically do is we'll do things in these phases. We'll start with the analysis, which is what do we want to do, and that's gathering requirements. Then from analysis, we'll go to design. That's where we'll have things like UML diagrams, like class diagrams, sequence diagrams, and things like that that are just saying, okay, here's how we want to approach this topic. After design, we go to implementation, and that's the writing code part. After implementation, we go to test. Typically, after test, there's a hard deadline, and then we go to rollout, where we're deploying this, and then to support. Let me talk about test and rollout in a bit more depth here. First of all, I mentioned that after test, we typically have a hard deadline. Well, here's the crux of testing. Is that, let's say you have a project, and software projects do tend to fall behind schedule. That's something that we pretty much have to plan for. What are we going to do when it falls behind schedule? Or how can we try to mitigate that, things we want to plan for? So let's say that testing is the last step before the hard deadline. Software projects running behind schedule. What gets cut? If you have to make a date, what gets cut? Well, you've already done the analysis, so that can't be cut. You've already done the design, so that can't be cut. You're probably working on the implementation, right? So what's left to be cut? Well, the only thing left to be cut is testing or quality. And these days, that's something you can't afford to shortchange. And why is that? Well, because the biggest asset that you have, one of the biggest assets, is your reputation. And if people do not have a good experience with something, they're very quickly going to go out and rate it accordingly and say, I didn't have a good experience with this. So to protect your reputation, you have to put quality first, and that means you can't shortchange quality. Okay, so how do we not shortchange quality if it's the last thing before our deadline? Well, there's an incredibly obvious and not obvious solution at the same time, and that is, instead of doing testing last, do testing first. Write the test first before the implementation. And then as you're writing the implementation, you can run the test to see if the tests pass. And that is test-driven design. But one thing we have to be comfortable with in test-driven design is that we're going to write these tests, and the tests will not work immediately because the code hasn't been written that the tests are testing. Okay, so that's testing. Now, I also want to talk a little bit about rollout. That probably sounds like, yeah, you write software, you roll it out, no big deal. And reality is, if you're cloud-based or web-based, yeah, it could be that straightforward, maybe. But then you also have to consider things like internationalization. So what are the local rules in one country versus another? What's local law? What's going to get you in trouble? Company I work for now is very much an international company with significant sales outside of the U.S. And I'll tell you that internationalization is something we think about a lot. What if we want to try different rollout strategies? Maybe we'll roll out in this market and see how response is, and if it's good, we'll keep going. We'll go to other markets. Or what if we want to roll out and kind of make sure that all our pipes are holding water? In other words, we want to make sure that we didn't miss any issues. And issues are likely to come up when we roll something out that's big. Now, let's think of another platform. If we think of mobile, rollout's a whole other consideration, because if you have a big mobile app and you have maybe 10 million customers, when you hit that rollout button, when you hit the go button, it goes on to 10 million devices that you don't own and you don't control. And what if you accidentally introduce something that is not fit for purpose? What if you introduce something that has a crash? How do you control that when it's on hardware that's in someone's pocket that you don't own? Well, these are big considerations in mobile. And for the last 6 years, my last 2 employers, I've been an engineering manager in the mobile space. And I'll tell you that this is very much top of mind. My previous employer, there were several times we had to turn things off after they were rolled out. My current employer, luckily, we've not had to do that. But it is an emergency brake that you want to be able to pull. So, yeah, this is waterfall, but nonetheless, still considerations we want to think about. Okay, this is what I walked through just a moment ago. I mentioned we're going to start by coming up with a requirements document. And we want to put that in some kind of document repository. For our video lectures, I'm going to be putting them in GitHub, and you see just like this, just as a README. Very straightforward README. README syntax is very easy to understand. We can literally edit this just by clicking on this pencil. And in here you'll see this is effectively the README markup for this page. So go ahead and cancel. A nice thing about it being in GitHub is it's living right there where the source code lives. Another good place to put it would be Confluence, which is very tightly knit with Jira. So there again, you have the documentation right where the work is being done, which is pretty handy. So we start with the requirements, and then what we do is elaborate the requirements into examples using given, when, then syntax. So given is a set of preconditions. When is steps that we will take on those preconditions. And then is the final result of the preconditions plus the steps that we took. Now, we literally use the words given, when, then. Like the sentences will start with given, with when, and with then. And the good part about that is everyone understands it. It's not really technical talk. So everybody can contribute. And what we'll find is that when we have the shared experiences of several people, they will tend to think of situations that one individual might not consider. So from there, we write the unit test, which is a very close reflection of the given, when, then. and then we can see the results of the unit test in our CI/CD pipeline. So pretend you're part of this group, and the requirement is, as a user interested in plants, I want to be able to search plants based on any part of the name, genus, species, cultivar, or common name, so that I can see a list of plants that match my search. So think about that for a moment. What examples would you come up with that match that in given when then syntax? And, think of a few different examples. For each requirement, we should have several given when then examples. We want more than one because we want to make sure we're covering edge cases. And we want to make sure we're covering a normal case and maybe several different normal cases. And there again, that's a nice thing about having input from several individuals, is that you get that shared experience. The first time I wrote a mobile app, I deployed it on the Google Play Store in 2013, and I had worked on this thing for over a year. I was really proud of it. And the trick is that every time I use the app, I use the exact same flow because I understand the app, I know what it does, and there we go. As soon as other people started to use it, they said, hey, it crashes here. I was like, oh yeah, I never actually used that part of it, or I never tried that flow. So there again, that's the benefit of getting perspective from a lot of different people. So think about that for a moment. What kind of examples would you come up with? Once we have the high-level requirements, we'll start breaking them down into examples using given when then syntax. So with the requirement we've created, is a user interested in plants, I want to be able to search plants based on any part of the plant name, we can come up with an example. Given a feed of plant data is available, when I search for redbud, then I should receive at least one results with these attributes, Cercis canadensis eastern redbud, because the redbud by definition is genus Cercis and species canadensis. Now why do this? Why do we like given when then? Well, one reason is it's just plain English or whatever your language of choice is, and so everybody can understand it and everybody can participate. And that's nice because if you think about one person, I might not think about all edge cases. But if we think of a group of people with varied life experiences, they're likely to think of more edge cases and thus give us better coverage. As a matter of fact, these given when then tests end up becoming unit tests. They become a script for a unit test. And then that becomes part of our test-driven design strategy. So what we'll do is state the preconditions in the given, state the steps to take in the when, and then in the then validate that the preconditions have been altered by the steps that we took in the when. And we want these to be very specific because, as I mentioned, we want to write a unit test from them, and a unit test needs to be very specific. A unit test can't say something like, when I open the app and I hit search, I see search results. Okay, that's too ambiguous, it's too broad. What are we searching for and what are the search results? We want to be very specific there because a unit test needs to be specific. So, given I have a 2014 Toyota Tacoma, when I paint it red, then I have a red 2014 Toyota Tacoma. You see, that's a lot more specific than given I have a vehicle, when I paint it, then it's a different color. We know that it's a 2014 Toyota Tacoma, and we know that it's red. So I have an example that we'll walk through here where I have a design document and a GitHub repo. And what we're going to do is we will start with the unit test that we script from this example. And it'll be true test-driven design where we write the test before we write the code. And therefore, the code that we're testing is not present yet, and therefore the test will not compile to begin with. And then the test will not pass. And our goal is, number one, to make it compile, and number two, to make it pass. And we do that by effectively implementing the code. And once the unit test passed, we know, okay, we've satisfied this given when then. When we've satisfied all the given when thens for the requirement, then we say, okay, we've satisfied the requirement. So we see that going from a very high level, just a concept or an idea, we can walk all the way down to the detailed implementation, and we can automatically see when the requirements have been satisfied. One integration that makes this really nice these days is the concept of CI/CD, or continuous integration, continuous deployment, continuous integration, continuous delivery. There are a few takes you can take on that acronym, but nonetheless, what it does is every time you make a commit, it runs a pipeline. And I have a screen capture of what a pipeline looks like here from Circle CI. So we see set up the environment, prepare environment variables, check out the code. What did you just write? Restore cache, take care of permissions, download dependencies, save cache, and now the important part, run tests. This run test will automatically run any unit test that we've set up properly with the right syntax in our project. And if they all pass, we get a green check. And this is a web interface, Circle CI is at least, one that integrates very well with GitHub. And GitHub integrates very well with Jira. And Jira many times is where we start this process of coming up with an idea and then breaking it into epics and then into tickets, so on and so forth. So if I'm a product owner, I can start my idea in Jira, and then once we elaborate it into stories, and then once we start working on those stories, I can drill down directly to the GitHub project, and more than likely the GitHub feature branch where this is being worked. And I can look for this pipeline. If I see red in there, then I think, okay, not complete yet. But if I see something like the one I've created here, where it's all green, I say, okay, provided that the unit tests have been written and the unit tests now compile and pass, which we can see by this indicator on the run test, and we can even see more details by clicking on the caret, then I know that my requirement has been satisfied. So that's a really neat way to take a bit of automation with our requirements and automatically communicate what our status is. The nice thing is that means a whole lot less status reports and a whole lot less interruptions because we're adhering to the Scrum principles of inspection and transparency. So I hope you found this video helpful, and I look forward to reading your comments. Thank you.